So good morning students. Today I am going to explain about Ohm's law. Ohm's law explains the relationship between voltage V, current I and resistance R, and used by electricians, automotive technicians, stereo installs. According to Ohm's law, at constant temperature, the current flowing through a conductor is directly proportional to the potential difference across its end. According to Ohm's law, V directly proportional to I, R V equal to R into I, whereas R is constant resistance of the conductor. This can also be written as I equal to V by R. So current I equal to V by R. Therefore, my dear children, the current is directly proportional to potential difference. The current is inversely proportional to resistance. So what is resistance? An electron traveling through the wires and loads of the external circuit encounters resistance. Resistance is the hindrance to the flow of charge. For an electron, the journey from terminal to terminal is not a direct route. Rather, it is a zigzag path that results from countless collisions with fixed atoms within the conducting material. The electrons encounter resistance, a hindrance to their movement. The essence of resistance is ohms. Factors affecting resistance. The following are the factors which affect the resistance. They are length of conductor, area of cross section of the conductor or thickness of the conductor, nature of the material of the conductor, and temperature of conductor. What is resistivity? It has been founded by experiment that the resistivity of a given conductor is directly proportional to its length or directly proportional to L. The resistivity of a given conductor is inversely proportional to its area of cross section. R is inversely proportional to 1 by A. Combining both 1 and 2, we get R inversely proportional to 1 by L by A, or R equal to rho into L by A, where rho is the constant known as resistivity of the material. The resistivity of a substance is numerically equal to resistance of a rod, that substance which is 1 meter long and 1 square meter in cross section. So resistivity rho equal to R into A by L. The unit of resistance R is ohm. The unit of area of cross section A is meter square. The unit of length L is meter. So putting these units in the above equation, rho equal to ohm meter square by meter. Therefore rho equal to ohm meter. The essence of resistivity is ohm meter. Children, just go through this table. Resistivity of some common substances are given here: conductors, alloys and insulators. Go through this table. The resistivity of alloys are much more than those of pure metals for which they are made. For example, the resistivity of manganese, which is an alloy of copper, manganese and nickel, is about 25 times more than that of copper. Alloys are used in making heating materials as alloys have very high resistivity, due to which heating elements produce a lot of heat on passing current. Alloys do not undergo oxidation easily even at high temperature. Now today, one more important concept: combination of resistors. Resistors can be combined in two ways: in series and in parallel. Resistors in series. When two or more resistors are connected end to end, consequently, they are said to be connected in series. According to the law of combination of resistance in series, the combined resistance of any number of resistances connected in series is equal to the sum of the individual resistances, that is R equal to R1 plus R2 plus R3, so on. When number of resistors connected in series are joined to the terminal of a battery, then each resistance had different potential differences across its ends, which depends on the value of resistance. But the total potential difference across all the ends of all the resistors in series is equal. When a number of resistors are connected in series, then the same current flow through each resistance. Now resultant resistance is connected in series. Observe children, my dear children, observe here figure. The figure shows three resistances R1, R2, R3 connected in series. So there are R1, R2, R3 are connected in series. Now suppose potential difference across resistances R1 is V1, R2 is V2 and R3 is V3. Let potential differences across battery be V. Then V equal to V1 plus V2 plus V3. So applying Ohm's law to the whole circuit, V equal to IR, equation 1. Applying Ohm's law to the three resistors separately, we get V1 equal to I into R1, V2 equal to I into R2, V3 equal to I into R3. Substituting 2, 3, 4 in equation 1, IR equal to IR1 plus IR2 plus IR3, or IR equal to, if you take I common, R1 plus R2 plus R3, and I and IN cancel, you will get R equal to R1 plus R2 plus R3. Therefore, we can conclude that the sum of the total resistance in a series resistance connection is equal to sum of the all resistances. Now resistors in parallel. When two or more resistors are connected between the same point, they are said to be connected in parallel. According to the law of combination of resistances, in a parallel, the reciprocal of the combined resistance of any number of resistances connected in parallel is equal to the sum of the reciprocals of the individual resistance, that is 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Where a number of resistances are connected in parallel, then their combined distance is less than the smallest individual resistances. Where number of resistances are connected in parallel, then the potential difference across each resistance is same, which is equal to the voltage of battery applied. Where number of resistances are connected in parallel or joined to the two terminals of a battery, the difference amounts of current flowing through each resistance, which depend on the value of resistance. But the current flowing through each parallel resistance taken together is equal to the current flowing in the circuit as whole. Thus, when a number of resistance are combined parallel, then the sum of current flowing through all the resistances is equal to the total current loss flowing in the circuit. Now, resultant of resistance connected in parallel. Children, observe here, the figure shows three resistances R1, R2, R3 connected in. You observe here parallel. Now suppose current cross resistance R1 is I1, R2 is I2 and R3 I3. Let total current in the circuit be I. Then I is equal to I1 plus I2 plus R3. Applying Ohm's law to the whole circuit, I equal to V by R. Applying Ohm's law to the three resistors separately, we get I equal to V by R1, I2 is equal to V by R2, I3 is equal to V by R3. Substituting 2, 3, 4 in equation 1, V by R is equal to V by R1 plus V by R2 plus V by R3. Therefore, V by R is equal to I into 1 by R1 plus 1 by R2 plus 1 by R3. So, V by R equal to what? Will I by R. Okay. So, I cancel R. Therefore, we'll get the 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. So, therefore, we can conclude that the sum total resistance in a parallel connection is equal to sum of the reciprocal of all the resistances. So, observe children, parallel and series connection differences. In parallel connection, if one electric appliance shows stop working due to some defect, then all the other appliances keep working normally. If one electric appliance stop working due to some defect, then all the other appliances stop working. Now, in parallel circuit, each electric appliance has its own switch, due to which it can be turned on or off independently. All the electrical appliances have only one switch, due to which they cannot be turned on or off separately. Each appliance gets same voltage as that of power source. In series circuit, the appliances do not get same voltage, 220 volts, so that as that of the power supply line. Overall resistances of household circuit is reduced due to which the current from power supply is high. In series circuit, the overall resistance of circuit increases due to which the current from the power source is low. So, heating effect of electric current. When electricity passes through a high resistance wire like a nichrome wire, the resistance of wire becomes very hot and produces heat. This is called heating effect of current. Okay, children, hope you understand about this small PPT which I made by me. So, all of you enjoy.